Yes, so now let's take more questions. Y is equal to tan inverse 3x minus x cube upon 1 minus 3x square. You see, somebody can take tan inverse x to be differentiated to 1 upon 1 plus, you have that form d dx of tan inverse of x as 1 upon 1 plus x square. So you can consider 1 upon 1 plus this much square and then chain rule differentiate this expression. This is one way, but it will be easier, it will be wiser to make some substitutions and simplify this before you differentiate. So for that you need to know that this expression resembles some standard formula in trigonometry. It resembles some of them. What is that? You had a formula 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Same pattern, simply in place of x it had tan theta. So that suggests us that if you just substitute this value, if you substitute that x as tan of theta, let that be. So tan inverse, and this becomes now 3 tan theta minus tan cube of theta upon 1 minus 3 tan square theta. Simply by substitution of x as tan theta, you have converted this expression inside the bracket as 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, and this is one standard formula. You can say this is tan inverse of tan of 3 theta. So easy. And then once you have got this tan inverse of tan, this will be removed and you got only 3 theta. Simplified. What was theta here? You need to refer this. You said tan theta is x. Tan theta is equal to x, so theta can be written as tan inverse of x. Okay, so you write it as 3 and in place of theta you can say tan inverse of x. This is the value of your y. You had to differentiate tan inverse of this expression, or you have to differentiate y is equal to 3 tan inverse. This is a simplified form of the same thing. And now differentiate with respect to x. You get dy dx is equal to 3. For tan inverse you have 1 upon 1 plus x square. That's it. Maximum you can write 3 upon 1 plus x square, and that's your answer. So you have seen here how a substitution of a trigonometric ratio makes this expression so simple to differentiate here. Okay. I'm taking just one more example of the same kind. So I'm erasing. This is okay? I'm taking now, say y is equal to, you write it as sec inverse of 1 upon and say 2x square minus 1 ddx of, or okay, this expression once again resembles something. What is this? 2x square minus 1 is similar to 2 cos square x minus 1 or 2 cos square theta minus 1. So let that x be cos of theta. But this will be possible only when you are fluent with your standard forms or identities in trigonometry, right? This makes it sec inverse 1 upon 2 cos square theta minus 1 by this substitution. When in place of x we have substituted cos of theta, this converts this. This is sec inverse 1 upon, and 2 cos square theta minus 1 is cos of 2 theta. Cos 2 theta is 2 cos square theta minus 1. So you should be able to identify that this expression is in particular pattern, which was this. Only then you will be able to solve. So this is now sec inverse 1 upon cos. 1 upon cos theta is sec of theta. You will be able to write it as sec of whatever angle you have. It was 2 theta, you write that 2 theta. Sec inverse of sec removed. It becomes now 2 theta. And then you have to recall what was theta. You have assumed that cos of theta was x. So theta will be cos inverse of x. Okay? Theta is equal to cos inverse of x. And you can see your expression, which was this, is simplified to this much only. And then you will say differentiate with respect to x. What do you get? You get it as dy dx 2 into d dx of cos inverse of x, which is minus 1 upon root of 1 minus x square. In fact, this is your answer. At the most, you can write it as 2 into minus 1 as, say, minus 2 upon root of 1 minus x square, and that is your final answer. This was the expression. Since it resembled 2 cos square theta minus 1, if you can recall that pattern, you will substitute x as cos theta. So 2 cos square theta in the minus 1 in the denominator will convert to cos of 2 theta in the denominator, or actually, since it is reciprocal of cos 2 theta, you can write it as sec of 2 theta. Sec inverse of sec of this angle leaves only 2 theta, and 2 as it is. For theta, you need to recall theta is this. Substitute and differentiate. So this is your simplification, only one step of differentiation, d dx of cos inverse of x, only the standard formula is to substitute it. Okay? Shall we take one more? So one more question I am taking, and then of course we can change the topic. So this expression is y is equal to, say, cos inverse of one expression, say sin x plus cos x divided by root of 2. This is the expression. And this is a particular form. Whenever it is a linear expression in sin and cos only, it may be sin x plus cos x, it may be like a sin x plus b cos x, some coefficient of sin and some coefficient of cos may be different. By chance here it is 1 and 1. But this is linear expression. It is not like sin square or cos cube, etc. Linear expression of sin x plus cos x, or 3 sin x plus 4 cos x, or a sin x plus b cos x type. In that case, you can identify this as cos inverse of, this is sin x upon root 2 separately, plus this is cos x upon root 2 separately. One step. Then you can say this is cos inverse of sin x into, you can write as 1 upon root 2, can we? And this is cos x and 1 upon root 2. After that, you need to recall it is in a certain pattern. Whenever it is outside this cos inverse, it means you need to convert this expression inside the bracket in terms of cos something, cos a plus b type or cos a minus b type. So you can recall this, it is cos inverse, and this is sin x, this is sine of some angle. In this example particularly, it is some standard angle, so you write directly. Otherwise, I will explain one more method for that. This is sine of 45 degree, but in calculus we won't use degrees. We will write in radians. Sine of pi by 4, that is 45 degree. Cos x, and this is cos of 45 degree or cos of pi by 4. So this is cos inverse, and I don't know if you can identify this, or else I write in the standard form. It was cos x cos pi by 4. What I am doing? Simply writing this first, and then I write this one. It will be easily, you can easily identify that pattern. Cos x cos pi by 4. This is sin x, then sin pi by 4. Cos a cos b plus sin a sin b. Cos of a minus b form. So cos inverse, then it is cos of a minus b, that is x minus pi by 4. recall that in the case of cos, when it is plus sign, this is negative. So cos inverse of cos will leave only that x minus pi by 4. Y is equal to that, only one step to differentiate with respect to x. dy dx equal to 1 minus 0, 1 for x, this constant, only 0, that is only 1. This is your answer. But here I need to make one more thing, that cos A cos B minus sin A sin B can be written either cos of x minus pi by 4, or you can say even cos of pi by 4 minus x as well. So you can say, or y is equal to cos inverse as it was, and then cos of, instead of writing x minus pi by 4, even you can say like cos pi by 4 cos x plus sin pi by 4 sin x can be considered as cos of pi by 4 minus x. That will leave y as only pi by 4 minus x. So when you differentiate, you will get 0, minus 1 or minus 1. In that case, both the answers will be correct, because what is the reason here? You can recall in your done earlier that cos of minus theta is equal to cos of theta itself. In this quadrant ASTC, what does it say? In the case of this cos, fourth quadrant, minus theta means this side minus theta. Cos of minus theta is equal to cos theta itself. For that reason, your answer could be dy dx as 1 or minus 1. That's all. So I hope it's clear. Thank you.